in this video we're going to talk about interval notation. Why do we need interval notation? Well, up until this point we've been solving linear equations and we've come up with an infinite number of solutions, one solution or no solution. Now we use interval notation when we have a whole bunch of solutions. So for example, if I end up with the solution that x greater than 2, this means that I can have a solution at any number greater than 2. So for example, 2.1 is a solution, 3 is a solution, 5.7 is a solution, 7 is a solution, 1,000 is a solution, etc. Now there's still a whole infinite number of solutions, but I want a way to indicate all the solutions. In other words, any value greater than 2 is going to work. If we look at this on the number line, which you maybe have done in the past, all right, I could display it this way. Remember, if I have a greater than sign without an equal, I would use an open circle on the 2, okay? Open circle means it can be any value almost to there, but it can't be equal to that value. In other words, 2 is not greater than 2, so 2 would not be a solution. And now this says x is greater than 2, so that would mean any value going this way, okay? So I could graph it on the number line this way to indicate it's any value greater than 2, or I can use interval notation. And the way interval notation works is that we're going to write it, it's going to look a lot like a point, but we write the smallest value it can be, comma, the largest value it can be. Now, I'm going to say smallest value it can be, but in reality, it cannot be 2. We have a way of distinguishing whether or not the smallest value is actually included in our solution or not. And that's where our brackets come into play. If we have an equal sign attached to our inequality, we will use square brackets, okay? So remember, equal sign, square brackets. One way I like to think of it is if I cover up the middle of my square bracket and I look at it abstractly, I have an equal sign right there. So equal sign, square brackets. If our inequality is missing the equal signs, we're going to use rounded brackets, okay? And we can also use combinations that look like this: one squared, one rounded, one square, okay? So depending on what we're trying to say, we're going to have to pick our brackets, and I'll show you some examples that'll clarify that in just a second. One more rule before we do an example, and that is if we're saying negative infinity or positive infinity, we always use rounded brackets. Now notice up here I said we put the smallest value on the left, the largest value on the right. Well, negative infinity is never going to be in the largest side, so we'd always use this bracket, this rounded bracket with negative infinity. And positive infinity is never going to be on the small side. It's going to always be on the largest side. So we'd always use this rounded bracket with infinity. And it kind of makes a little sense because we can never really get equal to infinity, right? Because infinity goes on for forever. So we're going to always use rounded brackets with negative infinity and positive infinity. Now, looking back at our original example, we had x is greater than 2, and I depicted it like this on the number line. So what is the smallest value, approximately, that x can ever take on? Well, I know it can't be equal to 2, but that's approximately the smallest value that it can take on. So I'm going to write the 2, and then comma, I'd put the largest value it can ever take on. Well, notice I put an arrow here. This is going to keep going and going and going out to positive infinity. Negative infinity would be in this direction. So because this is going on for forever to infinity, I would put comma infinity. Now we just have to decide on our brackets. No equal sign with the 2, so I'm going to use round, okay? And then infinity, we always use round. Okay, so this is interval notation. How would I distinguish this for a point? Well, you have to take it in context, okay? Obviously, this is not a point because I would never have infinity here. But if you have two numbers, you have to take it in context. Are you trying to represent this, or are you trying to represent a point? So keep that in mind. All right, let's do more examples. X greater than 3. This is almost exactly the one that we did. You don't have to write these out. I'm just showing you. No equal sign, so I'd put an open circle on the 3, and X is greater. My greater values are to the right, so it would look like that. Remember, infinity's here, negative infinity's here. So in interval notation, the smallest value approximately that this will ever take on is 3. The largest value is infinity. No equal sign, so rounded bracket, and we always use rounded bracket with infinity. Okay. X is less than or equal to 4. Again, I'm going to use my number line just so you can see it in play. All right, this has an equal sign, so I'm going to put a solid dot on the 4. And now it says X is less than or equal, so it's going to be all values going this way, okay? And now notice negative infinities down here, positive infinities up here. So what is the smallest value this will ever take on? Well, it's going to be this, right? Negative infinity. Smallest values are always located to the left on the number line. The largest value this would ever take on is 4. And now we have to do our brackets. Remember, we always use a rounded bracket with infinity or negative infinity. And now in this case, because I have the equal sign, the way we display that is with a square bracket. All right, so this right here, X less than or equal to 4, can be depicted in interval notation this way. Now, these look a little confusing, but they're actually probably the easiest ones that we do because the largest and smallest value are defined here. All right, so if it can be greater than -2, I'm going to put a round circle on -2, and that's going to be greater than as anything going this direction. But it's also less than or equal to 5. And so I'm going to put a solid dot on 5, and less than or equal to means anything going this direction. So my values of X can be any of these values in between. And now for interval notation, we look for the smallest value this would ever take on. Well, that's approximately -2, comma the largest value this ever takes on, which would be 5. And now we only have to worry about the brackets. No equal sign, curve. Equal sign, square. Okay, and now I often get, well, how do you know? Always go with the symbol that's closest to that number. So no equal sign is closest to -2, we're going to go curved. Because this means it can't equal -2. Equal sign is closest to 5, we're going to go square, because this means that it can be equal to 5, and that's what the square bracket means. All right, let's do a few more examples. X is less than -5. And now if you need to, you can keep drawing your number line. Otherwise, we're going to think about it. What's the smallest value it ever takes on? Well, it's going to always be less than -5, so that means it goes down to negative infinity. And then -5 is going to be the largest value it can be. Now, one clue is if the inequality opens up to the number, it's going to go on the big side. Okay, I hate to simplify things. If the inequality has the small end towards the number, it's going to go on the small side. So that's one way that you can kind of keep this straight. All right, let's worry about our brackets here. Negative infinity, we always use round. No equal sign, so we're going to use round. All right, this says X is always greater than -2. So I'm going to have -2 on the small side. Again, small end of the inequality towards -2, so it's going to go on the small side. And then it says it's going to always be greater, so we're going to go up to infinity. Again, no equal sign, rounded bracket, always rounded with positive or negative infinity. And our last example, again, I hope you're realizing that these are probably our easiest. All right, small n towards here, it's going to go on the small side. Big N towards here, going to go on the big side. All right, and then equal to -3, so that gets a square bracket. No equal sign, so that gets a rounded bracket. All right, I hope this helps with interval notation, because next we will be solving linear inequalities, and we will need to display our answer in interval notation. So I hope you understand the basics.